Hello and welcome everyone. Good evening. Most of the world parts now it is evening. So wherever you are, good evening very much and welcome to the course of Introduction to Well Control. So in this course, we are going to get the overview about what well control is and about the some drilling insights and what are the procedures we use for well control and what equipments are used in this operation. So I'll share my slides now and let's move on to slides. Okay, my name is Sanubar and I'll tell you something little about me. I have done graduation in petrochemical engineering. After that, I have done post-graduation in chemical engineering. I have also completed Shell's Round 1 Well Engineering program. After that, I have worked as drilling engineer in Gulf Drilling LLC, Muscat, Oman. And during my work tenure, I have been accredited as trainer for well control and well intervention from both IWCF and IATC. So this is about me. Now let's see about the course. Today we are going to cover overview of this well control. What is it about and why this well control topic is critical in our oil and gas operations. After that, we'll see the basic principle and procedure which guides this course. Then we will see some definition about kick, what is kick, what is the meaning of influx, and what is the meaning of blowout. After that, we will see how the fluids behave and how pressure acts in a well. Then we will see the relationship between volume and pressure, how both are interdependent on each other. Then we will see something about formation, that what types of formation pressure do we have. It can be categorized as normal, abnormal and subnormal. Then we will talk about bottom hole pressure and how that affects the fracture pressure of formation. While drilling, we have to take care about the hydrostatic pressure, bottom hole pressure and fracture pressure. So we will look about all these pressures, how they work. Then we will talk about the kick tolerance. Then we will talk about what are the indicators of kick, what are the shut-in procedure in case you get a kick, how to shut in the well, and how to keep bottom hole pressure constant during killing the well. And there are two famous methods for killing the well. One is driller's method and weight and weight method, which is widely used in industry. So we will try to have an overview of all these topics. So as this is a very short lecture, about 1 to 2 hours, let's see how it goes. So I will try to cover as much as I can in this short duration of time. After that, sometime we can have in-depth discussion also. If you want to take the full course, then there will be in-depth description of the topics. So let's start. Whenever any drilling operation is going on, what is the priorities for our oil companies? Their priority is, first is safety of personnel. Okay. First, their aim is to do production of crude oil. Okay. They need to do production, but they cannot do this at the cost of safety. Okay, at the cost of safety. They have to keep in mind the safety of people, because it is the process called as optimization. Optimization. Maybe you can produce at maximum. You have the capacity to produce oil at maximum speed or maximum efficiency, but if it is costing you safety of personnel, then you will reduce that production speed. It is called as optimization. So all the process is optimized based on is the safety of personnel maintained. After safety of personnel, the companies should prioritize the environment, that whatever process you are doing, it should not hamper your environmental quality. It should not cause pollution. In environment, you have all. In air, no air pollution should be there, like how to minimize or optimize it. Or obviously, you cannot eliminate it altogether, but you have to optimize such that you should get a good rate of production also, and your air quality should not get that much affected. Then water. You should not pollute your water. There is marine life, terrestrial life. So all those things should not get affected by the operation which you are doing. So oil companies are focusing on safety of personnel, safety of environment, and then comes safety of their own equipment and the well, which means their finances. Okay, because all this equipment, well drilling, it takes lot of money to do these operations. So if you are doing with good safety practices, you are using following the procedure, you are not damaging the environment, and you optimize the process for drilling, then you will have good profit also overall. So in this way, oil companies prioritize. Then if blowout occurs, if we don't take care of the well, okay, if we don't take care of the well and we get a kick, we will see in short time what is kick. But blowout means it's just all the influx from the well, it comes out uncontrolled. When you are drilling, the formation fluids come out uncontrolled and you have a big fire or explosion at your drilling. Okay, it causes fire or explosion. So it looks something like this, as you can see in the photo. It is disastrous event. Disaster for human life, disaster for environment, disaster for the company, finances. Altogether, it is a big disaster. So all this well-controlled training we are doing because we want to avoid this scenario, which you can see in the picture. Okay, we don't want to be in this situation ever. That's why we are getting the well-controlled training. This blowout can occur during different phases of well. If we talk about the phases of well, so there are major, if you want to divide, first is exploration. Okay, means you come at new area and you don't know oil is there or not, so you do different surveys, geological survey, and you do seismic surveys to find out that does this formation contain oil, can we do drilling here. Okay, all this exploration and study, it takes around 18 months to do that. So once it is done and the engineers, they are sure that, okay, if we drill at this place, we will get good amount of oil and it will be a profitable operation. Then the second phase of well starts, which is drilling. Okay. This is the second phase, drilling. After exploration, you decide an area that, okay, in this area, I'm going to drill a well. Then drilling phase happens. So during drilling, you can get a blowout like this. Okay, if you don't take care about the safety and don't follow proper procedure, you can end up in situation like this. It can occur during workover operations. Now, what is workover? In well's life cycle, as we seen, first is exploration. Once you explore, then you do drilling. Once you drill the well, okay, you drill the well and you reach the reservoir section. Here is your reservoir. All the oil is lying in this section. So now in this well, you will put a production tubing. Okay, this is production tubing. This is called as production tubing. And this tubing will transport all oil to the surface. Okay. This will take the oil from the formation to surface. So during this process is called as running production tubing. It is called as completion. Okay. Once the well is in completion, then it goes into production. You put the tubing inside, you're in completion phase, then production takes place, oil is coming. But obviously during production also you can face several problems. If there is problem with this tubing, you want to change the tubing, or any part of the component is damaged, you have to do some clean out operation, some debris has deposited downhole, then you have to do clean out operation. So all this maintenance of well, it is known as work over. Okay, so when you are doing work over operation, during work over or well intervention, you can get a blowout or kick if you don't take care of the safety standards. And the last phase of well is plug and abandonment. Plug and abandonment, which means once all the production is done, now you have taken out all the oil which can be taken out effectively. After that, you plug the well and you abandon it. This production, actually this goes around 20 to 30 years. Okay, once you drill a well, it produces around 20 to 30 years. If there's some problem occurs, some valve needs to be changed, or there is some corrosion, erosion somewhere in the equipment, then with work over operation you can change it or manage it. And once everything is done, all the oil is produced, now you feel nothing more can be taken out from the reservoir, then you plug the well and you abandon it. So during production also blowout can occur, as we have seen, and during the completion phase also blowout can occur. And if your equipments are not maintained properly, okay, there are many equipments which we called as pressure control equipment. Like this word PCE always comes in well control class. It means pressure control equipment. These equipments control the pressure which is coming from the formation, and they are containing this pressure. So if you are not maintaining these equipments properly, if their equipments are deteriorated, corroded, or it is not maintained properly, then it can fail. Equipment has a life, and its life decreases by time. Everyone's life as decreases by time. Same equipment's life also decreases as much it is in use. So you need to do frequent maintenance. If you don't do the maintenance, then it can fail and it can lead to catastrophic conditions such as blowout. It can occur offshore also, okay, in the water. In the water also blowout can occur, and it has happened also. There is a very famous incident which is called as Macondo blowout incident. It happened in Gulf of Mexico. So it was a lot of disaster, and we will see in this slide. That slide is also there about Macondo blowout. So it has such a huge impact. That's why in oil industry, people are so much focused about well control training. Every 2 years, they have to undergo this well control course. Okay, well control course, because training is very important, so that whenever such type of situation comes, you should know that how to react in this situation and how to control the situation to minimize the losses. So let's see some basic definitions about this. One term which you will frequently come across is kick. Now what is kick? When you are drilling the well, okay, this is your well bore, and this is your drill string, this is drill bit. So you are drilling. Here you have set your casing. This is open hole. Okay, you are drilling. So while drilling, sometimes if you go under balance, the fluid from formation starts coming in the wellbore. Okay, the fluid from formation, it starts coming in and it accumulates here. Mainly it is gas. Okay, mainly it is gas. Gas from the formation penetrates in our wellbore. So if this gas, it is called as kick. Okay, so by definition, it is influx of formation fluid. It can be gas, oil, water in the wellbore. And if you don't control this gas and you are unable to manage this gas, what will happen? When this gas will come at surface, okay, when this gas travels upward, gas has a property to expand. Gas has a property to expand. So when it comes to surface, it is in such a big volume, it has expanded, and if you don't control it, it will lead into this situation which is called as blowout. Okay. So main thing is kick, okay, but kick should be manageable. If you get your formation fluid inside the well, if you can manage it properly, if you can circulate out the kick, well and good. But if you are unable to close the well on time and you are unable to circulate it out, then it can lead to blowout. Okay. So this we already discussed. The impact of well control incident is so huge that blowout, it just do not happen by one mistake. Okay, never think that by one mistake only. If you do a single mistake, blowout will happen. If when we did the accident investigation and we saw the report, so it was clear that 80% of major catastrophes that involve a chain of 7 to 11 separate incidents. Okay, there are 7 to 11 separate mistakes, separate incidents, separate mistakes that that becomes the contributing factor for this catastrophe. So because whenever, if okay, somewhere you did a mistake, somewhere you did one mistake you did, but there is some backup which protects it. Okay, the process is defined such that everything is having a backup. While designing, the engineers have designed such that okay, if this is not there, this will fail, there is a backup for this equipment. If this does not work, there is a backup for this. So just by one or two mistake, this blowout will not happen. If you ignore the safety procedure or the procedure given by your company, you go on ignoring. So 7 to 11 mistakes you do, then only a catastrophe will occur. It is not that only mistake of one or two person or one or two things. So in safety, we usually see this Swiss cheese model, which says that how many contributing factors are there. As you can see, there is staff shortage. Okay, if for a particular work you require 12 people, but your company provided only 6, so how they are going to manage? There is staff shortage. There is inexperienced team member. Then the people who are there, if they don't have experience, they don't know their job, what they have to do, then also it is a failure. It is technical support failure. Then if you have not given them proper training, so they will not be able to get the monitor the signs, warning signs. Okay, in well control we have these warning signs that kick before the kick comes and before the blowout happens. There are many warning signs, many warning which the well gives you. It is not like that, okay, the well in 1 second it will have kick and 1 second it will have blowout. Before kick and before blowout, there are many warning signs. So people should be trained enough that they recognize these warning signs on time. If they just go on ignoring the warning sign, some warning sign come but they ignore, no, let it be, nothing will happen, nothing will happen. If this is their attitude, then this kick and blowout will happen. So it means there are many number of factors which lead to such incident. It is not, we cannot pinpoint on only one factor. Many number of factors, they come together and then this happens. So if you want to see impact of a well-controlled incident, this is a real life incident which occurred in April 2010. Okay, April 2010 in the Gulf of Mexico. It is called as Deepwater Horizon or Macondo blowout. So it killed 11 workers, and for 2 days the rig was burning. This burning, it went on for 2 days. They were unable to control the fire, and after 2 days the rig sank. And how many barrels of oil was spilled? It was 4.9 million barrel of oil. It spilled in this ocean. Okay, for over 87 days. So this is recorded as the worst marine oil spill in the history. So this is just to show you the impact of any such incident. So well control is safety, and if you want it to be effective, it has to be a culture. Okay, it cannot be you should not think that okay one day I will learn well control, or in one day I will implement well control. It has to be a culture, your way of life, your everyday. You have to implement it in everyday life. It is a attitude shift. You have to shift your mindset in that way. You have to be alert. You should not neglect any warning sign. And your behavior, if someone is giving you any feedback, your junior crew is there, if you are a supervisor, if they are telling you I think something is wrong there or something is not right, so you should go and check. Your behavior should be such that you should take positive feedback from your crew, and you should implement whatever they are saying. You should at least give attention. It is not okay, no, I know the best and I will not listen to you. Like this attitude should not be there. There is learning we can do from each other. And practices, you have to bring in good practices, so that good practices means it is already there. You have well control manual, you have safety manual. So whatever principle and procedure is given in that manual, you follow those. Maybe doing that takes more time, okay, more procedure, it takes more time, but it will ensure safety of personnel, safety of equipment, and safety of environment. So you have to think properly, act accordingly, and communicate. Communication is very important. Many incidents occur because people are not communicating with each other. Maybe the driller does something, but he does not inform the supervisor of his action. Then supervisor is in a different set of mind. Due to lack of communication also, accident happens. So whatever you do on the rig, what in your operation, you have to communicate with other crews also. Okay, this operation is done. Now we are going ahead to do this. That's why we are having this TBT. You know about TBT? It is toolbox talk. Before start of any operation, all the crew member who are going to get involved in that operation, they will come together and they will discuss what is the operation, what are the challenges in this operation we can face, then how to overcome that challenges. So all this thing is very important to discuss together and communicate. So before starting any job, you should know how will the wellbore operation be properly monitored. You should ask this question from yourself, that how I will properly monitor the operations. Then what will happen if something go wrong? It means, do you have a backup plan or not? If this equipment fails or if this procedure fails, then do I have a backup? This before startup only. You should have answers to this question. Do I have a plan or correct procedure if something goes wrong? And do you have the right equipment to do the job? And all the hazards, procedure, desired response, is it communicated to the crew? It means the toolbox talks, TBT. Have you done the TBT before the job? So all these things are very important before starting any job. So for any successful well control, we need actually three things. One is support from the human, okay? Human behavior, human skills, and how is his attitude. It is very important. Next is equipment, that whatever job you are doing, you should have right equipment. If only you are having the manpower, okay, this manpower you have, they are skilled also. They are skilled people and they have all proper training also. They have to do the job, but you don't provide them with equipment. How they will do? Without proper equipment, it is not possible to do the job. So you need human, your manpower, you need proper equipment, and you need the plan and procedure, because if you have all the manpower plus you have all the necessary equipment, but you don't know how to proceed, what is the plan, what procedure needs to be followed, so it is not possible to do the job correctly. So all these three factors are most important. You cannot pinpoint on one. All three are interdependent. Have correct plan and procedure, have correct equipment, and have correct manpower. So next we will see about the pressures. Three important pressure which comes in well-controlled class is hydrostatic pressure, okay, hydrostatic pressure, formation pressure, and fracture pressure. So this full game of well-control, which we say well-control, it is based on these three pressure: hydrostatic pressure, fracture pressure, and formation pressure. So it is very important to understand these pressures. So let's see what is hydrostatic. Hydro, as the name suggests, hydro is fluid or water, and static is when it is still. Okay, it means if in a container you take this water, okay, 10 feet of this, suppose 1 feet of water is there in a container. So this column of water will exert some pressure at the bottom, right? It will exert some pressure at the bottom. So this pressure is called as hydrostatic pressure. The pressure exerted by a column of fluid. Very simple definition. The pressure exerted by a column of fluid, it depends upon, and this pressure, it will depend upon what? Its density. Okay, density. So if I have two such beaker, one is having a density of, this is density of 10 ppg. Okay, same 1 feet height. This also 1 feet height. And in this, I have density of 8 ppg. So where do you think it will have more pressure, more hydrostatic pressure? Obviously, the one which is heavy, which is having high density, will have high pressure. If density is high, your hydrostatic pressure is also high. If density is low, your hydrostatic pressure is also low. So it depends upon density, and then it depends upon height. If same, for example, I'll give you example. Okay, now same, I have now 2 feet, 2 feet of column, 2 feet. This is 2 feet in height, and density is same, 10 ppg density. But if you change the height, so obviously the hydrostatic pressure here will be more. Okay. In the second case, the hydrostatic pressure will be more than the first case. So it means hydrostatic pressure depends upon two factors. What are those two factors? One is the density and one is the TVD. TVD means through vertical depth, which is the height of the column. So the hydrostatic pressure, it is very important to understand hydrostatic pressure depends upon two factors only, your mud density and your true vertical depth, which is height. So the formula for this, if we want to calculate mathematically, in this first case, how I will calculate the hydrostatic pressure if I need to calculate? We just multiply both of them. This hydrostatic pressure equal to what is the density? 10 ppg, 10 ppg multiply by what is the height? 1 feet. Okay. Now I need this pressure in psi, pound per square inch. So it is multiplied by a constant 0.052. This is just to convert this into psi. This is a constant. So as you can see, the formula for hydrostatic pressure, mud density into 0.052 into TVD. Simple. So whenever we are drilling a well, this mud column helps to balance the formation pressure. So it is very important that all of us should know how to calculate hydrostatic pressure and on which factors it depends. It depends upon density and height. If you want more hydrostatic pressure, increase the density. If you want less hydrostatic pressure, decrease the density. It is such relationship. Now, what is formation fluid pressure? One important pressure we have understood. Next is the formation fluid pressure, which we need to understand. Okay, when we are drilling, this is our surface. We are going to start drilling here. But this down, we have different types of formation. Okay, layer of many formation layers are there. There can be carbonate layer, layer of shale, layer of sand, layer of sedimentary rock. It is a mix of all the things. So all these layers, this actually contains small grains, okay, like this small grains are there in the formation. And between the small grain spaces are there. So in these spaces, we have our oil, we can have our water, we can have gas in these spaces. So this pores, how much pressure it is exerting, it is called as formation pressure. These pores are also under pressure. Why they are under pressure? Because so much is overburden pressure is there from the other formation. So all these fluids present here, they are under pressure. How much pressure is that? It is called as formation fluid pressure. So if we see the definition, formation fluid pressure is the pressure exerted by fluid which is present in the formation we are going to drill. That is formation pressure. So it means whenever we are drilling, okay, we are making our well ready for production. So at that time, what is our aim? Let's see by example. Okay, when we are drilling a well, this is a well. So this formation is continuously applying pressure from below. Okay, the oil, gas, water, all the fluids from the formation is applying pressure. Suppose 5000 psi. This is the formation pressure. So while you are drilling, your aim should be such that the mud column which is there, the mud which you are using, this column, its pressure should be at least equal to 5000, okay, equal to 5000 or more than 5000, 5200. Then only it will be able to balance the formation, right? If it is less than 5000, what will happen? If your mud column, this mud column, it is less than 5000, what will happen? If it is suppose 4800, then this formation fluid will be able to penetrate in the well. Okay, this will be penetrate in the well and you will get a kick. This is called as kick. So we say this is a under balance situation. Our well went under balance. Under balance means our hydrostatic pressure is less than our formation pressure. Okay. So if our hydrostatic pressure is higher, kick will not take place. But if our hydrostatic pressure is less than formation pressure, then kick can occur. So I hope these two concepts are crystal clear for you, because this is very important in managing the well control procedure. Now next important thing is fracture pressure. What is fracture pressure? If this is formation pressure we understood, then this formation, it is having a certain capacity, like you are keeping overbalance while drilling. So you can keep the overbalance 5200, okay, then your overbalance will be 200 psi. If you can keep the overbalance 5800 also, then your overbalance will be 800 psi. You can keep it 6000 also, you can keep anything 10,000, 20,000, but no, there is a upper limit. What is that upper limit? It is called as fracture pressure. Suppose fracture pressure of formation is 7000. It means if your mud hydrostatic, it reaches 7000, what will happen? The formation here will fracture. Okay, you will fracture the formation, and whatever drilling fluid is there, it will get lost in the formation. It is called as loss circulation. Okay, loss circulation. It means your pressure was, hydrostatic pressure was so high that it exceeded the fracture pressure of formation and the mud is lost in the formation. So fracture pressure is pressure which is necessary to overcome the formation pore pressure and strength of the rock matrix. And what will happen if you exceed this fracture pressure? Mud will be lost into the formation. So we don't want this situation either, okay? We don't want to lose our drilling mud and we don't want to go under balance. So our hydrostatic pressure should be such that it should be above your formation pressure, okay? It should be above your formation pressure, but it should be below your fracture pressure. It should be below your fracture pressure. So this is called as drilling window. This is your safe window, safe drilling window. If you stay in this range, you are good. If you go above or below this, either you will have kick. Okay, if hydrostatic pressure is reduced, you will have a kick, you will go under balance. And if you put too much overbalance, too much exceeding hydrostatic pressure more than fracture pressure, then you will have losses in the formation. So factor which influence the hydrostatic pressure, this we discussed already. It is influenced by the drilling mud density and it is influenced by the total vertical depth. It is influenced by your mud density and TV. Only two factors it depends upon. It means, what does it mean? See, this is a vertical column of a fluid, suppose mud, and its density or gradient is given as 0.5 psi per feet. It means how much pressure it is exerting at the bottom. Let's see, density is given 0.5 psi per feet. How many feet column we have? 1000 feet. So if we multiply these two, what do we get? We get 500 psi. So this hydrostatic column is exerting a pressure of 500 psi. Now the well is not always vertical, okay? Well is not always drilled vertical. It can be deviated and it can be horizontal as well. So what happens to hydrostatic pressure? If the well's shape, it is not like this, but this is just for explanation purpose. That same height, your vertical height, it is called as TVD. Vertical height is same here also, 1000 feet. So the hydrostatic pressure here also will be 500. If your well is inclined, then also the height, vertical height is same, 1000. 1000 multiplied by density, the pressure is same. Okay, if the well is of this shape or any container of this shape, the hydrostatic head of that column still 500 psi. It means hydrostatic pressure does not depend upon the shape. Okay, it does not depend upon the shape of the well, or it does not depend upon the measured depth of the well. It only depends upon the true vertical depth, straight. The straight depth is for true vertical depth. If you measure this line, so this line, maybe this line will come 1200 feet, okay? 1200. This is called as MD, measured depth, measured depth. And the vertical, if you draw a line vertically, then this depth is called as TVD. So all the pressure calculation, it depends upon TVD and not MD. You have to remember this. MD is used for volume calculation. When you want to calculate the volume, that what is the volume of fluid inside this well or inside this container, at that time only you will use measured depth, otherwise TVD. Same example is given for if formation water is 0.45 psi per feet, same how much pressure it is exerting. So 0.45 multiplied by 1000. Okay, so you will get 450 psi. So it does not depend upon the shape, it depends only upon the true vertical depth. So if you want to find the hydrostatic pressure, this is a simple example. The depth is given 11,000 feet. Okay. 11,000 is measured depth and 10,000 is TVD and density is given. So you use the formula density multiplied by 0.052 into TVD. This example is just to depict that don't use MD in your calculation. Don't use 11,000. You have to use the vertical depth. Okay, 10,000 and just multiply and you get the answer as 6240. You have used 10,000 for your pressure calculation, TVD. Don't use MD. This is the main point to remember. If you have two types of fluid, then you will find hydrostatic head of one fluid, okay? Hydrostatic head of one fluid. Multiply the mud weight into density, then hydrostatic head of other fluid. Multiply its mud weight and density and you add them. to get hydrostatic column of both. So as you can see, hydrostatic of light mud, you have found out. Hydrostatic of heavy mud, you have found out. And for total hydrostatic head, you add them. Add both the pressures. Same if you have 3 columns, you find each separately and add them. So like this, you are calculating the hydrostatic pressure. Okay. Now what is bottom hole pressure? This is also an important term. Bottom hole means, okay, this well is there. You are drilling it and it has mud here, mud inside the column. So hydrostatic head of this mud, hydrostatic pressure is 500 psi. Suppose something happened, you have to close in the well. Okay, your well is closed. And from surface you can apply pressure on the well. So suppose from surface you are applying 100 psi. Okay, 100 psi from the surface you are applying. So what will be the pressure at the bottom here, bottom of the well? What will be the pressure? It will be your hydrostatic head plus your surface pressure. 500 plus 100. So it is 600 psi. Okay. So this is called as bottom hole pressure. It is sum of your hydrostatic head, or if you are applying any pressure from the surface, so you add that to it. For example, this same example is given for explanation. This is a well of 9,000 feet. Its mud weight is 11 ppg. And from surface, you are applying 500 psi. Okay, this is 500 psi from surface. So what will be the bottom hole? So, pressure at the bottom of the well. So answer is, first you calculate the hydrostatic pressure, 0.052 into height into mud weight plus the surface pressure, you get 5648. So why we are interested in finding the bottom hole pressure? This bottom hole pressure acts downward. Okay, so all the time when you are drilling, this bottom hole pressure should be more than your formation pressure. Okay, this bottom hole pressure should be always more than your formation pressure. If this is less than formation pressure, what will happen? This formation fluid will come inside the well and you will get influx, kick, and blowout can happen. This is worked example. This we have already seen. Hydrostatic pressure plus surface pressure is your bottom hole pressure. Okay. How to calculate formation fluid pressure? This formation, it can also be of 3 types. But mainly 90% of the formation, it is filled with water. Okay. Our earth, 90% down if you see, it is filled with water. So for calculating the formation pressure, we are taking reference for water. If for water, the formation pressure ranges between 0.433 to 0.465. This is from range because it is taken of fresh water, density of fresh water and density of salt water. So if your formation is falling into this category, then we say we have a normal formation. If your formation pressure gradient is more than this range, then we say we have a abnormal pressure formation. And if it is less than this range, then it is subnormal pressure formation. Now let's see a little bit how your formation can become abnormal or subnormal. So there are various effects which are happening in the formation which can lead to it becoming abnormal. Effects such as there is artesian effect, there is faulting, there is salt dome effect, gas cap effect, charred sand, overburden. Let's see little by little, one by one. And for subnormal, we have mountain drilling or depleted reservoir. So what is this artesian effect? So if it means if you are drilling a rig here on at this location A, okay. So the water source is here at the surface from your water source. So from here you have calculated that okay, this is the height of the water column. So this much will be my formation pressure. But same if you are drilling at point B, okay, point B. The water source is coming from high mountain. The water source is from here. So if you are drilling considering water source for only this height, So it is not true. You have to consider from here, this full height, it will exert that much pressure. This formation will have pressure equal to this much height, okay, from the mountain to the point we are drilling. So this is called as abnormal pressure when your source of water is higher than where you are drilling the rig. It is called as artesian effect. So if this question, if we see gas bearing formation is overpressured by an artesian effect, which of the following condition has created abnormal pressure? So whenever you see artesian effect, you should know the source water is higher than where we are drilling. It means the formation water source is located at higher level than the rig floor. This is the correct answer. Next, it can be due to under compaction of shale and clay. So as we have seen that formation can contain many layers. There are many layers. Layer of sedimentary rock, layer of shale, sand, clay. So shale is a type of rock which does not have permeability, okay? Very low permeability. Permeability means ability to flow. The fluid which is present in the rocks, they don't have the ability to flow or they don't have a path, like they don't have the road from where they can flow. So it is like impermeable. So if you have shale here, okay, this rock is, this layer is shale. But because of the overburden pressure of formation above, all the formation fluid which is present here, they will be squeezed and they will try to rise up, okay, because over pressure, they will try to rise up. But here we have shale. So it will just accumulate here because this shale will not let the fluid to pass. Understood? So all this fluid which is accumulated here, it is under high pressure because of pressure from every side squeezing it to go up, but it is unable to go because here you have impermeable layer of shale. So see this section, red one, maybe because here shale is there or impermeable section is there, your fluid is unable to penetrate up, so this forms a high pressure zone. So this is called as under compaction of shale or clay. And this is very wide phenomena. Like worldwide, we find this as the most common phenomena for abnormal pressure. So this I have already explained what is this. Sediment like shale or clay are buried and water is squeezed out due to overlying weight, due to compaction. But if this water cannot escape, okay, because it has low permeability, it cannot escape, then the pore pressure or the formation pressure, it becomes very high. This trapped fluid support part of the overburden, so rock does not compact as expected. So worldwide, what is the most common cause of abnormal formation pressure? It is under compaction of shale or clay. This is most common worldwide. Next, we have gas cap effect. Similarly, if you have gas and liquid in a reservoir, and same it comes gas and liquid because gas is having low density, okay, and oil is having moderate if we compare with water, and water is having high, okay, both three we compare, water is having high. So over time what will happen, the low density fluid will try to go up, right, it will try to go up. So this red is gas, all the gas will go up, after that oil will be there, and after that water will be there as per the density. So this is called as gas cap effect. So when you are drilling, you have a envelope of gas sitting here, okay, which you have not expected. So that also leads to abnormal gas cap formation. And how can you find out if you have this or not? All this is done in your survey, okay, when you do the survey of formation, geological survey, seismic survey, at that time you know if you have any abnormal formation or not. This is calculation. We'll skip for today the calculation because we have less time. And there can be faulting also. Faulting, like if you have any earthquake or we have tectonic plates in our earth, we have tectonic plates and these plates move continuously, okay, they are moving, continuous movement is there. But if due to earthquake or something, it moves so much up like this, see, up and down. So this pressure, it was normal when it was flowing like this pressure was normal here. But it was normal for this depth. Suppose depth of 2000 or 2000 feet, this pressure was normal. But when it shifted to suppose depth of 1000, then now it contains the same pressure which it had at 2000. So it will have high pressure, what we expected at as 1000 feet. So it due to faulting also we get abnormal pressure. Then if there is any shallow gas like biogenic methane from bacterial action, all the gas accumulate, that gas also it gives abnormal pressure. Charging sand. This phenomena means you have already drilled a well. Okay, this somewhere this well was drilled, old well drilled, and now it is abandoned. So you have casing and cementing, but if suppose your cement job was poor, here your cement was not good, cement poor. So from this reservoir, gas can migrate up, and this you are drilling this, okay? You are drilling this failure, and this is another formation. So from one formation to other formation, this can migrate if you have poor cement job or you have a connection between formation due to any reason. So this will charge this formation. This red formation will charge the blue formation to high pressure. So here also you get abnormal pressure. So these are various reasons for abnormal pressure. If you are drilling in mountain, then also you will get abnormal pressure. About this fracture pressure, okay. Fracture pressure means the pressure at which formation will fracture. So while drilling, we don't want to fracture the formation. We just want to overcome the formation pressure, but we don't want to go to the upper limit, which is fracturing the formation. Why? Because we will damage the formation and all our mud or drilling fluid, it will be lost. If we fracture, it will just go and lose in the formation. We don't want that. So it is very necessary before drilling, you should determine what is the fracture pressure of this formation, and we should never cross this. So this window I have already explained what is this drilling window. Your bottom hole pressure should always be greater than formation, but it should be less than fracture. This is the window. If this is your formation pressure and this black line is your fracture pressure, so you should drill such that you always stay between this window. Then you are safe. If you go beyond here, your formation will frack. If you go this side, then you will have kick. You will go under balance. Now how to control well. So there are different methods to control the well. One is primary, secondary and tertiary. Primary means the first line of defense, which is our mud. Mud is our first line of defense. When we are drilling, this mud hydrostatic is balancing our formation. But if due to any reason, this mud hydrostatic is reduced, okay, this hydrostatic pressure is reduced and it unable to balance the formation and we get kick, then we use the secondary well control. Secondary means equipment. Here we are using equipment, our pressure control equipment. Such as there are many pressure control equipment. We call it as blowout preventer, BOP. Blowout preventer are there, many valves are there, many pieces of equipment work together to form a secondary well control. We will look into it. And if from both primary and secondary well control you are unable to manage the well, then comes the tertiary one. Okay, it is not common and our aim should be that we should not reach this stage. Okay, this cannot be done by the drilling crew itself. It is done by specialist people. Then you have to drill a relief valve and it is a very expensive and complex operation. So always our aim should be if any influx or kick comes, we should able to manage it by our primary and secondary well control. So primary is maintaining sufficient hydrostatic head. Secondary is when our primary control is lost, then we can use our secondary equipment like BOP. You can close the BOP and secure the well. And if you are unable to manage from primary and secondary, then you can use your tertiary, which is drilling a relief well or capping by specialist. It is very expensive and dangerous. So what is primary well control? It is the use of our mud hydrostatic to balance the fluid pressure in the formation. This is primary well control. Okay, this calculation we will skip for today. So when primary well control is lost, then secondary well control comes to the rescue. In secondary well control, we have DOP. So if you get a kick while drilling, okay, you get an influx. Here you have an influx of gas. Then what you will do, you have blowout preventers here, okay, blowout preventer which can close around this drill pipe. It will close around this drill pipe and it well will be closed. Once the well is closed and secure, okay, closed and secure, still influx is there in your well. So you need to circulate out this influx. We don't want this gas. We need to circulate this influx out and balance the well again with kill mud weight. It means our mud weight was not sufficient. So the mud weight which is sufficient and we use for killing, we call it as kill mud weight. So you have to circulate the influx out and you need to kill the well. Okay, the term is kill the well, means kill the pressure which is coming from the well. You have to balance that pressure. That is secondary well control. Equipment used in this is your blowout preventer, wellhead, casing, cementing, choke line, kill line, choke manifold is there, drill sing in the hole, your wellbore fluid, and there is accumulator system, there is met gas separator. There are many equipment which work together to control the well. So these things which control the pressure from the well, we term it as barrier. Okay, barrier. Barrier can be defined as any object that prevent flow from a source. Okay, here our source is well, so it prevents flow from well. So our barrier can be fluid like our drilling mud, or it can be any piece of equipment like POP is a barrier, tubular is a barrier, casing is a barrier, safety valve is a barrier, cementing is a barrier. All those things comes under barrier. And all the barrier, they work together to control the well. It is not like if you have just a working DOP, but your casing cementing is not good. Okay, casing cementing is in poor condition, then you will not be able to do well control. All the barriers should be in good condition to achieve a successful well control. Therefore, it is called as a barrier envelope. Okay, it is called as barrier envelope. And the thing which are all this individual element, these are called as barrier elements. All single elements, they come together to form an envelope and control the well pressure. See this envelope, already explained you, all the elements come together to form an envelope. And depending upon which operation you are doing, it depends upon which operation you are doing. Like you are drilling a well, or you are in completion phase, or you are in production phase. Depend upon which operation is going on, your barrier will change. Barrier is not a fixed thing. It is a dynamic thing, okay? It is going to change as per which operation you are performing. So before the start of any operation, it is very important that you identify your barrier, because this is like a safety harness. When you are working at height, safety harness is there, helmet is there. So these are barriers which will not let you fall. So same when you are drilling the well, you have barriers which will prevent flow from the well. If anything goes wrong in the well, if the formation fluids are coming up, so these barriers will hold it for time being, and you can close and secure the well. It will give you time to kill the well. So identifying these barriers before the start of operation is very critical and important. So these barriers can be classified as primary barrier or secondary barrier. As we have seen, our mud is primary barrier, and our pressure control equipment, PCEs, are our secondary barrier. And it can be classified in terms of fluid and mechanical also. Fluid means if you are using any fluid like mud, water to control the flow, or if it is a piece of mechanical equipment like a blowout preventer, any safety valve, then it comes in mechanical. So primary barrier is first line of defense which control the flow, which is directly in contact with the reservoir, which is our drilling pipe. And secondary well barrier, if primary fails, then secondary comes for rescue. So as I told you, barrier is not a fixed thing. If you are drilling, then your fluid is primary barrier. But when you are in completion, okay, then this fluid is not your primary barrier. Primary barrier becomes the packer, okay. Depending upon which operation you are doing, you are producing or you are in abandonment phase, completion phase. So your barrier will also change. Primary and secondary barrier will change. So it is important to identify. So while drilling, you should always have two barriers in place, okay? Two barriers. So that if one fail, you have second one for backup. So whenever you are drilling, you should make sure you have two barriers. So suppose in simple term, when we are drilling, our mud hydrostatic is first barrier. And if anything goes wrong, we have BOP, pressure control equipment, that is our second barrier. So these barriers, we cannot rely on them blindly. We need to test them that they are in good working condition or not. Okay. So that testing of barrier is called as leak and function testing or pressure testing. There are many words for it, but it means you just test it that it is in good condition or not. So pressure testing, it can be done on two ways. If see this is a well and this is a barrier, so you can test it in two ways. One is uh, you have formation pressure from below, okay? Formation pressure is there. And from above, if you decrease the pressure, okay, low pressure, you bleed off pressure from above the barrier. Here you have low pressure, and this side you have high pressure. So if your barrier is working, you will not see any leak up, right? There will be no leak due to pressure differential because it is holding the pressure. But if your barrier has failed, it means this pressure will leak and come up. This is called as negative test, or it is also called as inflow test. Inflow test means from below your pressure is high, downside of the barrier pressure is high, and upside of the barrier you decrease the pressure to check for any leak. And if you do opposite of this, you have a barrier and you have your formation pressure here, okay. If suppose this is 5000 psi, so from above you will apply more. From above you will apply more pressure, 5800 suppose psi. And you will see that this pressure is transmitting down. If it is transmitting down, you will see a decrease in pressure. It will be 500, 5700 or 600. You will see the pressure is holding or it is leaking or decreasing. So this test is called as positive pressure test. Okay. So one you can do by positive pressure testing or you can do by negative pressure testing, which is also called as inflow test. Then once you do the test, you confirm, okay, your barrier is holding in place. Then you have to save the data, okay, for record you have to save it. On that chart or on that pressure test document, what should be there, which type of test you have done, positive or negative. What was the test pressure, like you have tested till 5000, 10,000 psi. What was the pressure, what type of fluid you used while testing, and which components you have tested, how much volume you have pumped. So all this data you have to make a document and save it, chart and document. Then managing the risk. In well control, it is very important that you manage the risk because any operation you do, risk is there. Okay, all the operations are risky, but you should be able to identify in risk management. What is the main principle? You should be able to identify hazards. Okay, that this thing can cause some trouble to me. This is hazard form. You should be able to identify the hazard and its potential, how much it can harm, and is there any way I can reduce its potential, identify its potential, and how to reduce it. Okay, reduce, or it is also called as mitigate. You need to identify the risk and you should know the process to mitigate it, how to mitigate the risk. So you have risk factor related to mechanics of drilling oil well, okay, from the mechanics, or you can have risk factor which is associated with human performance. Like abnormal pressure is a risk, but abnormal pressure it is the characteristic of formation only. You cannot do anything with it. Uh, so it is called as mechanics, risk from mechanics. It does not have any human factor. But there is human factor also responsible. Like if you forgot to do something right, you have not followed the safety procedure, you have not followed the checklist, then that is human induced risk. So you have to train the crew to how to assess the risk, monitor it and reduce it. Risk assessment is very important. Then next, checklist. Maintaining a checklist is very important because see, human memory, we all have like limitation to our memory. Everyone cannot remember everything. So before the start of operation, you should have a checklist that okay, these points you have to check. If you maintain a proper checklist, then it is easy. It is like mitigation of risk. You are mitigating the risk of going wrong. So checklist is very important before any job. Then companies are doing drills. Drills means in an event, if something kick occurs, how to close the BOP. It is called as BOP drill. So this is like kick is not occurring, but they are doing the practice of how to open and close the BOP. So that in time, when actual time will come, when actual kick will come, and they have to open and close the BOP, secure the well, they should be sure that what is the procedure I have to follow, and they should not panic. So there are many types of drill which occur. Like some drills that are monthly basis, quarterly basis, based upon how is the company policy. But this drill means practice. This practice session occurs of this well control training. So that all the crew should be familiar that if such situation occur, what procedure we have to take and what is our role and responsibility. So this is part of training. There can be pit drill, trip drill, strip drill, power choke drill, diverter drill. Many types of drills are there. Okay. So what is why do you conduct a trip drill when running or pulling out of hole? When they are running in hole or pulling out of hole, we are doing the trip drill because we want to provide the drilling crew with training. If there is kick while tripping, then how they should react and what procedure they should follow. Now blowout. Coaching. Coaching is risk management. Another important is coaching. Like anything you are doing, you should question all the actions. That why you have taken this action or this decision. What is the logic behind it? So it will be like continuous learning and monitoring. You have to explain the philosophy, the logic, why we do it, provide words of wisdom, share your experience, and pass along rule of thumb. Like some rules are such that which are passed on from generation to generation, which will be called as rule of thumb. That no need to think about that. It works like this only. So there are some rule of thumb. So you need to pass it to your group. Now, what can cause kick? There are many factors which can cause, but all factor will lead to what? Your hydrostatic pressure. Hydrostatic pressure should be less than formation pressure, right? If any time your hydrostatic is less than formation, it will happen. Now we will see the factor which reduces the hydrostatic pressure or which lead to this condition of getting kick. So kick and blowout difference we have already seen. Kick is unwanted or unexpected fluid which we get into the formation. Okay, kick is the unwanted fluid which we get from the formation in our well. But it can be handled. Okay, it can be circulated out safely. But if kicks are unable to be circulated out safely, then it can quickly become blowout. If kicks are not managed properly, it can become blowout. So this is also called as kick tolerance. Kick tolerance. Every well you drill, it is having a tolerance. Suppose this well you are drilling, it has a kick tolerance of 10 barrel. 10 barrel. What does it mean? If any gas kick comes in and its volume is 10 barrel, then you can safely circulate it out. Okay, this formation or this well is having the capacity to safely circulate out 10 barrel kick. But if your kick is 12 barrel, then it is a problem for you. If it is more than your kick tolerance limit, it means while circulating out, you can fracture the formation, you can have lost circulation, and you can have different complications. So it is very important before drilling, you should know what is the kick tolerance value for your well, and you should quickly shut in the well. These barrels, it depends upon what, when influx starts to come in, it gives us warning sign. So as fast as we respond, we have to respond very fast. If we respond very fast and we close in the well on time, then we can get less volume. But if we take time to recognize the kick, if we take time to recognize the warning sign, then we will get big volume of kick, maybe higher than our kick tolerance, and it will be difficult to manage and it can become as a blowout also. So blowout is uncontrolled flow of formation fluid to the surface or another formation. So your philosophy to handle kick is catch them early. Why catch them early? If you catch them early, you will get volume less. Okay, volume of kick will be less. If volume is kick is less, it is easy to handle and circulate out. Okay, the driller should be able to conduct flow check. Flow check means what? When you are drilling, your pumps are on. Okay, here you have mud pumps, mud pumps, mud pumps. They pump in the drill pipe, okay. From the drill pipe, mud is circulated up from the annulus out. So flow check means if you have some doubt, you get some warning sign that your well is flowing, you are getting influx. You off the pumps, okay, you off the pump and you observe. When pumps are off, you should not get any return flow. This is called as return flow. So you should not get any return flow. But if your pumps are off and still you are getting return flow. So from where this flow is coming? This is coming from the well. This is coming from the formation. This is called as positive flow check. Okay. Your flow check, when you check the flow, it is positive. It means you got a kick. And if your flow check is negative, negative means you are not getting any return flow. When you off the pump and your well is still, okay, your well is still, you are not, it is not flowing. It means you get negative return, negative return. It means, okay, everything is okay, you can continue drilling. So you should empower driller that if any warning sign comes, you please conduct flow check. And if you get a positive flow check, please shut in the well on time. It is driller's responsibility. Driller's responsibility to close in the well at time. Then you have to assume all the kicks are gas, okay? All the kicks, they are gas because gas is the worst of all influx. Influx can be gas, water, and oil. So out of these three, the worst is gas. Why? Because it has high compressibility factor. Compressibility factor means it can expand a lot. Okay, it can compress a lot and it can be expanded a lot. So when it comes up, if its volume was suppose 5 barrel, when it is circulated out at surface, it can become 50 barrel also. Okay, like this. So it has very high compressibility factor. But if it is water or oil, they does not have that much compressibility factor. If your water kick is 10 barrel of water kick, it will come to surface as 10 barrel only. It will not become 20 or 30. So that's why gas kick is the worst case scenario. So we have to assume if we get any kick, assume it or take it as worst case scenario as gas kick. Don't assume it as water or oil till it is confirmed. And safety is highest priority as always. Put most qualified person on the job and train all the drilling persons. Your kick can be liquid, gas, and liquid means water or oil, and gas. So unless and until it is confirmed, treat all the influx as gas because it is most dangerous. So what can be your cause of well kick? So as we saw, if there is less hydrostatic pressure. Why there is less hydrostatic pressure? Suppose if your mud weight is low, right? Hydrostatic pressure depends upon the density of mud. So if your mud weight is low, you will have less hydrostatic pressure. If mud weight is too low, maybe you got incorrect data from the field. If your barites means these are substances which are used to weight the mud, to increase the weight of mud. Okay, to increase the weight of mud, barite is added. So maybe barites are not enough or it is settling down. It is not, mud is not properly conditioned, then you will get low mud weight. Or you can, the causes of well kick can also be if your formation pressure increase suddenly. Why it will increase suddenly? Because from seismic survey, we got wrong data. Suppose unreliable data or wrong data. We were expecting our formation pressure to be 5,000. So we have balanced the mud to 5,200. But while drilling, we came across a formation which had a formation pressure 5,400. So obviously I will get deep. So either your mud weight will be low or your formation pressure will be high than expected to get a kick due to faulting or water injection or charging of sand or artesian effect. All those factors we have seen already. Then there is a term phenomena which is called surging. Surging means what? When you are tripping in, okay, when the pipe, you are tripping in the pipe. So if you go in with very high speed, okay, it is filled with mud, very high speed you are going. So it is causing a surging effect. Surge pressure is also added on the formation. When you are going in with high speed, you get a surge pressure. Similarly, when you are going out, tripping out the pipe, and if you are doing it very quickly, okay, quickly, then a vacuum-like effect will come here, which is called as swabbing. Okay, swabbing. If you are moving out quickly, it is swabbing. If you are running in quickly, it is surging. So surging means extra pressure on formation. If too much pressure you apply on formation and you exceed the formation pressure, what will happen? Losses will happen. Losses. And if you are going up with high speed, so what can happen? Vacuum like effect, it will swab a gasket. Okay, if your gases are there in the formation, they will be swabbed in because of this vacuum effect. So there is losses due to surging if we are running pipe too fast, and if our mud condition, its viscosity, gel strength, mud cake strength, it is not good, or we have ball bit or stabilizer, then we can have losses due to surging. So there is a piston effect while running in. It is pressurizing the wellbore below the pit. When you are running in, this acts like a piston and it is applying pressure downwards. So if the speed is too much, the pressure will be too much and it will fracture the formation and your mud will be lost in the mud will be lost in the formation. Okay. If any weak formation is there, it will break. If formation will break down, mud will be lost, then your level also will be dropped. Mud level will also drop in the well. If mud level will drop, hydrostatic head will drop and gases from the formation can enter in your wellbore. So this is due to surging. Then swabbing, I explained. Swabbing is opposite of surging. When you are going up to it too quickly, this acts like a piston. This bit, it acts like a piston and it swabs in any gas which is present in the formation. So what is the correct method? You should run in hole slowly, and if you are pulling out of hole, that operation also you have to do slowly, and you have to monitor your well on trip time. Monitor well on trip tank to see if there is any losses or gain from the well. Then only you will come to know if your well is flowing or everything is under control. Okay. There can be human error also, like failure to fill the hole properly. All the time your hole should be full, but suppose you are tripping out a pipe. When you trip out one stand of pipe, so the volume of that pipe, now this is gone. So instead of that, you should fill in mud, okay? If you are unable to fill the correct level of mud in the well, then you will have reduced hydrostatic head. Then also you can get kick. Human error can happen due to lack of communication, lack of teamwork, lack of understanding the job, their attitude. Okay, so good practice is to follow a trip sheet. Trip sheet means if one stand of pipe you are removing, on that sheet it is written, if I remove one stand of pipe from the well, then how much volume I have to fill in the well, and monitor that on trip tank, that much volume is gone into the well on. So that is trip sheet. You have to maintain the trip sheet. Maintain your equipments. Okay. So there is a calculation for this. We will skip this calculation for today. So causes, okay. Causes we have seen. Loss circulation also we have seen. What is loss circulation? If we exceed the hydrostatic pressure too much, such that the weak formation, if the hydrostatic pressure is that much, that a weak formation breakdowns and all your fluid is lost in the formation. That is loss circulation. Calculation we will skip for today. Tripping, when we are tripping in pipe, you can trip in pipe, or it is tripping in or tripping out of hole, pulling out of hole, pull out of hole. So you should always monitor on trip tank and you maintain a trip sheet for this to know if you are having any losses or if you are gaining anything from the well. So it is important to maintain the trip tank and trip sheet. Trip tank is usually a small tank. It has a capacity of 40-50 barrel. So this tank, the active tank which we are using for drilling, it is very big tank. So if any 1 or 2 barrel change is there in active tank, we will not be able to determine because it is so big tank. If 1-2 barrel change, 1-2 barrel losses or gain is there, we will not be able to recognize. So that's why we are using this small trip tank when we are running in or pulling out of hole, so that if any 1 barrel or 2 barrel loss is there, it should be recognizable quickly. Okay, I have got 1 barrel peak, I have got 2 barrel peak. You will be able to recognize quickly. But if you use active mud tanks, then it is very difficult. Unless until it becomes 10 barrel, you will not be able to see any difference on your active tank. So this is important about tank flow check. Also, I told you what is flow check. You off the pumps and you see if your well is flowing or not. If your flow check is negative, means well is not flowing, everything is okay, you can continue your operation. But if flow check is positive, then you have to close in the well. Close in the well, shut in your POP and monitor the well. Okay, this is for trip sheet. So as I have told you that before a kick happens, it gives you many warning signs, okay, many warning signs. You should not ignore those warning signs. Then you will get less volume of kick. Warning signs such as, let's see what are the warning signs. If you get suddenly you are drilling, okay, your rate of penetration is 45 feet per hours. Suddenly it came as 95 feet per hour, okay? Your ROP changed suddenly. So you have to stop operation and you flow check if your well is flowing or not. If it is flowing, shut in the well. If it is not flowing, then maybe you have a change of formation, okay? Your formation is changing as there are different layer of formation. So maybe there was a hard formation and now you went into a soft formation. That's why your ROP changed. But you need to check. It is not like you got a drilling break increase in ROP and you have not taken care of it and you are just drilling ahead. Don't do it. You have to stop and do flow check. If you have to monitor the cutting, like when you are drilling, okay, drilling, the fluid from the annulus, it is going in the shell shaker. So it is having all the cuttings which we are cutting from the formation. You monitor the cutting. What is the cutting size? What is the cutting density? That also indicate the warning signs. If you are getting too much gas or water in your mud, the mud which is returning from here, if you have too much gas or water in it, then also it is a warning sign. You have to stop and check the trip gas, connection gas, background gas. The returning mud, you have to, this mud which is returning from the well, this came in touch with the formation down here. So it carries all the information about the formation. So it is very important to check all the properties of this returning mud. Or if you see any change in the flow line temperature, then also you have to stop and flow check. So flow check is needed. No delays. Okay, no delay in flow check. Don't think twice in flow checking. Stop the pumps and flow check if your well is flowing or not. So those were warning, but there are some positive indication. Positive indication means you don't need to flow check. Positive means certainly the well is flowing. If your return flow rate increased, means if you are drilling and your return flow was 60%, but now suddenly your return flow becomes 80%, 70%. So from where this extra flow is coming? Obviously from the well. This is positive indication. So here don't waste time to do flow check, just shut in the well, okay? Directly shut in the well. If you see increase in pit level, okay, when you are monitoring on pit level, if your pit level increase, so from where that extra volume is coming, it is coming from the formation. And if you see any decrease in pump pressure, okay, so because this formation pressure, it is acting upwards, so your pump pressure will decrease. This is also a positive indication. You shut down the well, close the well, secure the well. And if you shut down the pump, okay, when your pumps are off, so your well should not flow, but if the well is flowing with pump off, then this is positive indication that you have to close in the well, secure the well. Close in the well immediately, okay? Don't waste any time. Otherwise, your influx volume, peak volume will go on increasing. So positive indication, increase in return flow, increase in pit level, and if your well flow with pumps off. So how to close in the well and whose responsibility is this? Responsibility is for the driller, okay? Driller will be the first one to see all these warning signs and positive indication. So it is his responsibility to close in, driller. Now how to close the well? There are actually two methods to close the well. One is called as hard shut-in method and one is called as soft shut-in method. Okay. So how this method is determined, this is already pre-planned. Okay. The company will tell the crew that if any kick happens, you have to use hard shut-in or soft shut-in. It is in company policy. But how this policy is made? This policy is made depending upon your formation strength. Okay. Formation strength. What is the strength of your formation? If your strength of formation is good, high formation strength, you can use hard shut-in, okay? But if you use hard shut-in on any weak formation, when you shut in the well, all the formation down, it will break, okay? Because hard shut-in is like suddenly you are blocking the way. Suddenly you are blocking, you are suddenly closing the well. So it is sending a shock on the formation, okay? There is a shock on formation. So formation should be hard enough to handle that shock. But if the formation is weak, its fracture pressure is very low, then you have to use soft shut-in procedure. So soft shut-in, it closes gradually. Okay, it closes the well gradually, and there is less shock on the formation. There is less shock on the formation. So these two types of methods are there for closing in the well, hard shutting and uh, soft shutting. Okay. So our circulating system, it looks like this from the pump. Okay, here we have the pump. We are pumping drilling mud. This is called a standpipe. From standpipe in the drill string, then it will go in the drill string. It will exit the bit. It will come out of annulus. From the annulus, it will go shale shaker because it will have cuttings and all with it. So it will go in shale shaker, desander, desilter. All these are called as solid liquid separators, okay, or separators. It means it separate the solids, the cuttings from our drilling mud. And then again the mud which is cleaned, it is sent back to the tank. So this round circulating system we have, that muds again, it go to the pump and like this round and round, it forms a circulating system. Okay. So influx characteristic, if we see, so we have seen influx can be of three types. One is oil, one is water, and one is gas. Okay. So what characteristic it have? Let's see. Kicks are described by the formation material that enter the well. Which type of material? Is it liquid, water or oil, or is it gas? So most kick contain some gas. Gas is inevitable. You will have gas. If you have water kick also, you will have some amount of gas. So all kick should be treated as if they are gas until proven otherwise. So what happens? These gas, they are soluble in our drilling fluid. Okay, it has solubility in our drilling fluids. So if methane gas is there and you are using oil-based mud, our mud, drilling mud, it is of two types. It can be water-based, okay, water-based mud, depends upon your drilling program, and it can be oil-based. So if it is water-based, good. You can easily determine the kick. If some gas is coming from the formation, you can determine. But if you are using oil-based mud, then it is very difficult to recognize the kick. Difficult. Why it is difficult? Because the gas get dissolved in this oil, okay, get dissolved. So you are unable to get any signal or recognition that gas is dissolved in it. H2S, H2S is very toxic gas, okay, this is very toxic. So it is also oil-based mud, so it is very dangerous situation if we have methane or H2S or CO2 in the reservoir and we are using oil-based mud, then it dissolves in it. So a gas kick is easier to detect in water-based mud? True. If we are using water-based mud, it is easy to detect a gas kick. And if we are using oil-based mud, then it is hydrocarbon is more soluble in oil, okay, not in water. So this statement is false. Hydrocarbon are soluble in oil, so it is hard to detect. Okay. So this gas law also, it comes in well control class. It is called as Boyle's law. Okay, Boyle's law. It states that PV is equal to nRT. N and R are constant. We are just focusing on pressure, volume, and temperature. Pressure, volume is directly proportional to temperature, or pressure is directly proportional to temperature upon volume. It means if volume will increase, pressure will decrease. Okay, if volume will decrease, pressure will increase. This equation is very much used when we are killing the well. Okay, to understand the well killing procedure, it is important to understand the pressure, temperature, volume relationship. Now this gas, it has another characteristic which we call as migration. Suppose you close in the well, you get a kick and your well is closed. Okay, it is closed. And now you are not taking any action. You just leave it as it is. So what will happen? This gas will not stay here. It will start migrating. Okay, this gas, it will start migrating and it will come up. Again, if you don't take any action, it will start migrating and it will come up. So what is the danger in it? Suppose the formation pressure was 5000 psi. So with this 5000 psi, it is coming up. Here also pressure 5000 psi. When it comes on the surface, 5000 psi, it is very large pressure. Here we have pressure gauges and here we will read too high pressure, maybe 10,000 psi, 12,000 psi. So it is the all your well, the bottom hole pressure will also increase, your surface pressure will also increase, your casing shoe pressure will also increase. So due to gas migration, all the pressure around the well, it will increase. So this is a very dangerous situation. Any equipment can fail, any barrier element can fail if the pressure is so high in the well. So we cannot allow this situation to happen. Therefore, there is a choke, okay? Here we have a choke manifold. From this choke manifold, we open the choke and we allow this gas to expand, okay? We allow this gas of expand so that it will have a controlled migration. We are controlling its migration. We cannot let it migrate on its own. So this is the concept for open well migration. So we have seen the shut-in methods. Okay, shut-in method is hard shut-in, and one is soft shut-in. Hard shut-in, it closes in just one step. Close the BOP, close BOP, and your well is closed. But in soft shut-in, you have to do two steps. Okay, two steps. First step, you will close the BOP, but here your choke line is open. After that, you will close the choke line. Second step, you will close the choke line. So here the well is closed gradually, so it is soft shutting. Here the well is closed suddenly, it is hard shutting. It will give a shock on the formation. Okay. Shut-in procedure I have explained you briefly. Now, as we have limited time, I'll just give you an idea about the killing procedure. Well killing, what is well killing and how it can be done? Okay. What is the goal of this well controlled method? We have to circulate influx out. Okay, circulate influx out of the well. But while circulating the influx out, we have to maintain our bottom hole pressure constant. Okay, the main idea is to maintain bottom hole pressure constant. So we can kill the well in two ways. Okay, there are two ways to kill the well. One is by circulating. If you can circulate through the drill string, it is called circulating method. But due to some reason, if you cannot circulate, okay, you cannot circulate. So there is a non-circulating method also. Non-circulating. In which situation you cannot circulate? Suppose if your bit is plugged, okay, all your bit is plugged, so you are unable to circulate, or there is any problem with the drill string, you cannot circulate through the drill string, then you can use non-circulating method. In circulating, you have two types. One is driller's method and one is weight and weight method. Okay. And in non-circulating, you have volumetric method. If due to some reason you are unable to circulate, then you use this non-circulating method, which is volumetric method. But both the methods, in all the methods, the main idea is keep the bottom hole pressure constant while circulating out the cake. So there is driller's method, weight and weight method, volumetric method. Okay. Many others are also there, but these three are important. And bullheading means if you have any toxic cake, there is some toxic gases are there like H2S and all. and so this gas you cannot allow to come at surface. So if kick happens and it contains H2S gas, so you bullhead means you apply pressure on the formation such that all this influx is squeezed inside the formation again. Okay, you squeeze the influx in the formation again. This is done only in emergency. This is not a usual procedure. This you only do in emergency, because whatever debris is there inside the well, all this also will go inside the formation and your formation can be damaged permanently. We don't want to do any formation damage. So this method, bullheading, is done in emergency. Our usual method is driller or wait and wait. And if due to some reason we are unable to circulate, then we use volumetric method. Okay. So all the methods have their own benefits, their drawbacks, that we can see what are the benefits and drawbacks. Okay. So the basic principle is you have to keep bottom hole pressure constant. So when you close in the well, you get two types of pressure, okay? When you close the well, this is your bit. You have closed the well, here you have influx. So there are two pressure gauges. This is your mud, okay? Here also you have mud, and this is your gas influx. So you have two pressure gauges here. One is drill pipe pressure gauge and one is your casing pressure gauge. Okay, casing measures the pressure in the annulus, and drill pipe, it gives the surface pressure applied on the drill pipe. So your drill pipe pressure will read 500 and your casing will read 650. Your casing pressure is always higher than drill pipe. Why? Because you have influx on the annulus side. This influx is having less weight. So in order to balance the density of this weight, this casing has to apply more pressure to balance this formation pressure. So always your casing pressure will be higher than your drill pipe pressure. So when you close in the well, you have a drill pipe pressure and you have a casing pressure. And both are different. Casing pressure is usually higher because your influx is lighter. It is gas. So the two methods, I will just give you a brief overview. What is the major difference between the two? In driller's method, you don't have to wait, okay? Whatever mud is there in your system, your original mud with which you are drilling, you can use that original mud and you can start killing operation, okay? You can start killing. How you will circulate out with that original mud. You will pump that original mud inside the drill string and the gas peak you can circulate out from the choke manifold, okay? So in one circulation, your gas is out, your gas out or influx out. But the well is still not killed because this mud is not sufficient to balance the formation. So in second circulation, you pump a kill mud. Okay, kill mud means heavy mud. You pump a heavy mud. There is a calculation that how to calculate your kill mud weight. So with that calculation, you will pump a heavy mud inside and out, and then your well will be killed. So driller's method, it takes two circulation, okay? Driller's method is a two circulation method. In one circulation, influx is out, and in other circulation, the well is killed. But wait and wait method is what? Wait, as the name suggests, wait. First you are waiting. Waiting for what? To prepare the kill mud, okay? You prepare the kill mud, and this is your well, this is your influx. So you start the operation with your heavy mud only. You start pumping the heavy mud, kill mud, you start pumping with your kill mud. So as you are going down, this influx will come up and it will go up. So in single circulation, your whole well system mud also you have changed to heavy mud and you have removed the influx also in a single circulation. Okay. So this is a one circulation method, wait and wait method. And this is a two circulation method, Triller's method. These two are widely used, and if due to some reason we are unable to circulate out of well, then we use volumetric method, which is non-circulating method. And if there is any emergencies there or any toxic gas is there, so in emergency we can use bullhead also. Bullhead means whatever influx is there, you squeeze it back into the formation. Okay, so I think I will stop here because we have exceeded like our time limit. It was around now 1.5, 1.2, 1 hour 45 minutes. We have already done the lecture. So if any detail, there are many topics still remaining. All the pressure control equipment are there. It is a big topic actually, full well control. So I have tried to give you overview little bit about the PNP, the principle and procedure. Equipment is still left, the pressure control equipment and the detailed procedure of how to kill the well. So if anyone is interested in knowing the full well control, the PNP, the equipment, or if you are interested in getting IWCF certified or IADC certified, IADC well control courses certified, then you can take the full course. I hope you got some knowledge from this course. Okay, we will end here. Thank you.
Thank you very much, Mrs. Sanobar. It was very great and helpful session. If anyone has any questions, please you can ask Engineer Sanobar, and she would be happy to answer you.
I'm Saidul from Bangladesh. Thank you, ma'am, for your nice presentations. But I have a request. Can we get the record or the slides, please? Can we
Okay,
get this?
I don't have any problem in sharing the slide. I can share my slide, but how to share? Okay, I will coordinate how to share the slide. No
The
problem, I
video?
can share the slides.
Thank you, ma'am. And ma'am,
Okay.
ma'am, if we want to enroll you in your course, then what is the process? How can we enroll you in your course?
That information also you can get on the WhatsApp group after the session is over. I think this Mr. Ahmed, he will coordinate about how to take the full course.
Yes,
Okay, ma'am.
I'm
Thank you.
Engineer Ahmed. I
Thank
am the
you, ma'am.
moderator of BigTech. I will publish everything relating to the course in the following days, and for the recording video, we will do the editing to it, and we will publish it tomorrow, inshallah.
Okay. Okay. Thank you.
If anyone has any question, please ask Engineer Zunabar.
Thank you so much.
I hope you all have gained some knowledge from it. If anything is not clear, you can ask me again. No problem.
Yes, ma'am.
Ma'am,
Absolutely. We gained some knowledge. It's a great time to with you. Thank you for your time. Thanks, ma'am.
ma'am, someone in chat
Thank
box
you for
asked
the
you a
appreciation.
question. Ma'am,
Oh, okay.
someone
I'll
in
check
chat.
the chat box.
Okay.
Let me see.
I have another question here.
Yes.
Yeah, you were explaining about the formation pressure and fracture pressure. What can
Yes.
we do if we have a formation pressure that is increased or is over the mud, but at the same time we have another formation in the same well, we have a low circulation. What can we do in this scenario?
Okay. Let me try to answer it. Okay, so if I understand it correctly, your question is, suppose in a well, we have a formation, okay, here you have high formation pressure, okay, 5,000 suppose. And in another other formation, you have low formation pressure, 4,000 something. This is your question. Like if you drill from here, okay, this with a mud weight, if you drill from here, So you calculate depending, your mud weight will be depending upon this formation. When this formation is drilled, then you set a casing here, okay? This is for
Okay.
setting casing. If you have different formation zone, you drill with a certain mud weight which balances this 5000 psi, and then you set a casing. Once the casing is set, then there is no hazard of lost circulation, or there is no hazard of getting a kick. This happen when we are in open hole, right?
Okay.
Open hole.
Okay.
If casing is set, we are safe, no issue. So the next section which we are going to drill, we can change our mud weight depending upon the next section. If it is having low pressure, we will reduce our mud weight, right? So the well design is done in such a way that what pressures we are going to encounter in our well, and at what depths we are going to have that pressure. That's how our casing is also designed, that at what depth our casing should be set. If we have a different formation, we will set there another casing. We will drill with another drilling mud and set different casing. If another type of formation, then we will set another casing like this. So it comes under well design and casing setting depth. Okay.
Okay.
Understood?
Thank you. Yeah, it was
Oh,
understood. You have to run the casing and isolate
yes,
one of
yes.
one of those
Isolate this.
formations.
Yes,
Mhm.
yes, yes. Correct.
Thank you. Thank you so much.
Welcome.
There is a question from Engineer Joes in the chat box. Please
Okay,
follow
let
it.
me see. What? Yeah, that only I have answered. What can we do if we have a formation that is increase of the mud, but at the same time we have another that is losing circulation? This we have answered. We can isolate those formation by setting casing.
Anyone want to ask Engineer Sanobar anything? Okay, thank you very much. And we will open the chatting on the WhatsApp group. So if you have any inquiries, you can ask either in the group, and Engineer Sanobar will either reply to you there. And thank you very much for being with us today. And as I said, the recorded video will be edited and published tomorrow, inshallah. And also, all the course details will be published tomorrow or the day after tomorrow, inshallah. Thank you very much for being with us today.
Okay, thank
Thank you
you.
very much,
Have
sir.
a nice
Thank you.
day. Good night, all of you.
Good night. Good night.
Thank you, ma'am.
Engineer
Thank you very
Sanobar.
much.